So my research is focused on carbonaceous chondrites to understand their formation in the early solar nebula, as well as secondary processing they've been subjected to on their parent bodies. For the accretionary work, I've studied fine-grained rims that surround many chondrules in carbonaceous chondrites and determined that they likely represent nebular dust accreted onto the chondrule surfaces while the nebula was still weakly turbulent. A figure from that work is shown here in the upper right. And then I also explore how carbonaceous material is deformed, heated, and aqueously altered on the parent body after accretion. Laboratory techniques that I use include X-ray computed tomography or X-ray CT. Data from that is shown here in the upper right. Electron microbeam instruments like the backscattered electron images on the lower right, and then also thermal infrared spectroscopy. And from a spectroscopy perspective, I've largely focused on how heating modifies the spectral signature of chondrites that have been both naturally and experimentally heated. I'm currently a participating scientist on the OSIRIS-REx mission, and I primarily work with the thermal infrared instrument OTIS to document evidence of aqueous alteration and possibly heating that Bennu's carbonaceous material might have experienced. And finally, I was notified about a week ago that I've gotten a LARS proposal recently funded to develop a noble gas X-ray CT technique, which we will be using to examine 3D microporosity in carbonaceous chondrites in preparation for return samples from hopefully OSIRIS-REx and Hayabusa 2.